Today we're going to learn how to make a box and whisker plot. A box and whisker plot is just another way of organizing your data, but it does give you some important information that you might be able to use, and it's just a different way of organizing it, and it does have a purpose as to why you might choose it to organize your data. And we'll talk about that in just a minute. Okay, in order to make a box and whisker plot, you need to put your data in order, numerical order, because we're going to find the median. Okay, so these are our numbers over here. I'll give you a moment and we'll get them written down, but let's just write them down in order as you do them. Okay, looks like our smallest number is going to be a 1. So it looks like we have 3 ones. Okay, then I have 2s. 1, 2, 3, 4 2s. Does that get them all? Okay, then what's next? 3s. 1, 2, 3 3s. Okay, 4s. 1, 2, 3. 5s. 1. Is that it? 6s. Looks like 3. 7s. 3 is a popular number. 8s. 5, 6. And 9s. 2. And doesn't look like we have any 10s. 11 and 14. Okay, so how many pieces of data do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So if I had 6 rows of 5, that makes it 30. So did I get them all? All right, now we're going to find the middle number, which one way to start is if there's 30 pieces of data, it's going to be right around the 15 mark. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This one's 15 from this direction. So you're trying to find the middle number, which would be what? 6. Okay, so 6 is your median. Now this is the first thing then that you're going to plot on your number line. You can make yourself a number line, and you always want to include at least the smallest number. I would probably even include 0 and then 1 above the highest number, so I would extend it out to 15. Remember, you include all your numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, because it's just like a number line where you're counting. Okay, the first thing is I make a box or just a bar above my 6, my median, and I label it. That's 6. Okay, for step 3 then, we find the medians of the lower and upper halves of the data. Okay, now when I'm talking about the lower and upper halves, I have to include this 6 into my lower data because I didn't actually use that 6. I used the average between those two. So I'm going to find the median of my lower half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it'll be 1, 2, 3, 4, 5, 6, 7. This is 8. 1, 2, 3, 4, 5, 6, 7, 8. So there is one middle number, which is 3, and this is called the lower quartile, or sometimes called the first quartile. And you're going to make another bar above the 3 and label it. And then connect those, making the lower part of your box. And then let's do the same for the upper half. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my median of the upper half, or we call it the upper quartile, would be what? 8. Okay, so I make another bar above the 8, connect, and label. Okay, and the last step then is to plot the extremes. That's your low and high data, and that'll make your whiskers. So my lowest number is a 1. I put a dot there and connect it to my box. And my highest number is a 14, and I connect it to my box. Now, sometimes if you have what I call an extreme piece of data, we call that an outlier, and you just put a little star. Okay, so we want to put an outlier is an extreme piece of data. And it's usually just one piece. And in this case, I don't know that I have any really extremes. Now, if I would have had a 20 in here, then I would have just put a little star out here, a little asterisk, and labeled it on the 20, and that would have been an outlier. Remember, it's something that causes your data to really be thrown off. Okay, now let's talk a little bit about what does this data show us? What's the purpose of making a box and whisker plot? Well, it's just like the 4 quarters in a ball game. This is the first quarter, second quarter, third quarter, and fourth quarter. And in each quarter, you have the same amount of time, correct? Well, in each one of these sections or pieces, we have the same number of pieces of data. Whether or not the box is small or a little longer shows you how those pieces of data are either spread out, in other words, there's a good variety, or are a lot of them the same. We can see that between 6 and 8, we have a lot of 8s, a lot of 7s, and a lot of 6s. So we can say that that data is very compact. Those numbers are closer together. A lot of them are the same number. Whereas if I look between 3 and 6, okay, they may be spread out just a little more. Don't have quite as many because like 8s, I don't have quite as many 8s involved in that. Okay, you can see that between 8 and 14, the numbers are really spread out because you see I don't have any 10s, I don't have any 12s, and I don't have any 13s. Okay, so that's why this little whisker here is a lot longer than this whisker, because the pieces of data are just spread out more. Over here, I have more 1s and 2s. In other words, I repeat the data more than once. That's why you see shorter sections, like this shorter whisker. But still, there's the same number of pieces of data here, 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 and here. This kind of like divided into 4 equal pieces, and it just tells you how close your data pieces are together. So if I have a little part of a box that's really close together, what's that tell you? A lot of numbers in there. Okay, really a lot of your numbers are in that area. But if I have a box that's way spread apart, we know that those numbers are spread apart. Same pieces of data, just spread out a little more. Any questions on how to make a box and whisker plot? Sometimes these are just termed box plots. All right? Sometimes you'll see that make a box plot, and they'll say just box, not just box and whisker.